Hello, college algebra students. This is section 2.3, and this is the second video in this particular section. The first video was on the domain and range of a function, and this video will be on the increasing and decreasing characteristics of a function. As you can see in the first diagram here, it kind of just classifies what it looks like to have a function increase versus a function decrease. And in this case, when you think of a function or when you look at a function, you read it from left to right. If a function increases, it's going to go upward from left to right, and if it's decreasing, it will go downward. So you can see these three different intervals, and if we just look at the very first one from A to B, as we travel from A to B, the function f is getting larger, or it's increasing. So it's going upward as we move left to right, versus the region from B to C. The function is decreasing from B to C as we read left to right. And so these two characteristics of a function are formally described with the following definition. It's kind of hard to understand these definitions, I think, but I'll just walk you through it really quickly. So if a function is increasing, the function at a certain x value is less than a function at the next x value, assuming that x sub 1 is less than x sub 2. So what this means is kind of this difficult definition to understand, but what it means is that the function at x1 is less than the function at the next x value as you read left to right. So when it says x sub 1 is less than x sub 2, that means that you're reading left to right. So it's looking at one x value and then it's looking at the next x value on the interval. Again, this is much easier to understand or identify visually, and so we're going to focus on looking at graphs to be able to determine increasing and decreasing. Okay, so let's take a look at example 5. With example 5, we have a graph of the weight in pounds, W, that's the vertical axis, and the age of a person, X, that's the horizontal axis, and that's in years. And so we're looking at the intervals, the intervals in which the function W is increasing and decreasing. Okay, so when we look at this particular function and read left to right, the region from 0 to, it looks like about, I'm going to say age 25, okay, that looks like W is increasing during that entire region. So our first interval for increasing is from 0 to 25 years old. And that ends up making sense, right? If we think about the weight of a person, they certainly are gaining weight during those periods of their life. And then there's another portion, sorry, let me get blue. There's another portion where we have a person gaining weight that looks like it's maybe between 35 and 40. So two different periods of time where people are gaining weight and that function W is increasing. And then there is just one portion right here between, looks like 40 and 50, for which W is decreasing. And the other regions that we see in the graph are horizontal, and those would be considered a constant portion of the graph, and constant would mean that it's neither increasing or decreasing. I chose to put parentheses around these intervals, so we're not really including the endpoints. For example, if we look at this particular endpoint right here, that's kind of a transition between increasing and constant. Or we look at this endpoint right there, that's kind of a transition between increasing and decreasing. And so we're not classifying those within increasing or decreasing. We're just kind of leaving those off. So we're considering these open intervals. Okay, let's look at example 6. This is why I have the calculator over here on the screen. Hopefully I can get it to work because it's been a little bit problematic. Oops, sorry. There we go. Okay, so I have the function typed in. If you could follow along with either your calculator or if you're able to go to the MCA calculator that we've done, we've used in class a number of times, that would be great. So I typed in the function y equals, so go ahead and take a minute to do that. Once you type it in, we want to take or look at a graph that would be a nice visual, because again, we're kind of relying on the visual here in order to assess whether it's increasing or decreasing. So when you go to your window, most of you will have a standard window, which would be x from -10 to 10, and then y from -10 to 10. So here's the window that you might just kind of by default have on your calculator. And in this particular case, it's not a very good window because the function sort of disappears at the top of this, and we are unable to see the maximum or the top of the function. So in order to help with that, we're going to increase the y maximum, as well as I think it's a little bit too wide here. So let's go to the window and maybe make x -5 to 5. And then for y, let's do -10 to maybe, let's just do 35 and see if that's enough. And then if you hit graph, you can see enough of the function to be able to determine, the increasing, decreasing nature of the graph. And I'm going to try to just put a little sketch in here so that we have something to write on. Okay, so here's our function. And I'm going to just highlight the portions that are increasing. So we know that this is increasing. We also know that's increasing as we read left to right. And then this is decreasing and that's decreasing. And so we need to figure out the x values. We need this x value. I'll put a question mark there. We need this one, which looks like 0, and then we need that one. And if we can find those particular x values, then we can set up the intervals for which it's increasing and decreasing. Okay, so the way we do this is that we go to second and calculate on the calculator. So second and the trace button, which is calculate. And what you'll see is two different options. Number 3 is minimum and number 4 is maximum. So like in this particular case, if I want this very first point, that's going to be a maximum. We'll talk more about this in the last video for this section. But this particular maximum will allow us to find our x value. So we're gonna go to second and trace and choose option 4. And on the calculator, it's going to ask you for a left boundary. So if you scroll over to the left of that maximum, so if you can see my cursor there, it's to the left of the maximum, and hit enter, it puts in a vertical kind of boundary point. And then you want to go to the right of that, and as soon as you're to the right of that, you can hit enter. And again, what you're telling the calculator is that the maximum exists between those boundaries, and then it asks you to guess. So you kind of get close to the maximum and hit enter, and then it identifies the maximum for you. And that particular maximum is -1 and 5. So I'm going to label that here, -1, 5. And then we would do the same thing with our minimum, which is that one kind of in the middle there. So the minimum is here. And then we have another maximum right there. So I'll walk you through each one of these. I'll do the minimum next. Whoops, sorry. That's going to be option 3 this time. So again, go to your calculate menu, choose option 3, and then left bound. So I'm left of the minimum right now, and I'm going to scroll over to the right here. I'm going to be right of the minimum, and then I'm going to kind of guess right about there. And of course, that minimum is what it looks like. That's 0, 0. And then I'm going to go back to the calculate menu. I'm going to choose maximum and do the last maximum, which is up here. So I'm going to go sort of right of it, maybe about there, and then and then this side, and then I'm going to go up and guess right about there for the maximum. And that maximum is 232. Okay, all right, so that's the process with regard to identifying those, we call them extreme values. But again, we're looking for the x value, which is -1, 0, and then 2. And so if we, I'm actually going to do part C here really quick. So if we look at when f is increasing in between -infinity and -1, so that blue region that I highlighted, and then again from 0 to 2. And then f is decreasing from -1 to 0, that's that green region that I highlighted, and then again from 2 to infinity. Through this process, we also have the domain and range, or we could identify the domain and range. That was the first part of this section. This particular function, any value of x can be put into the function. There is no value for which the function would have any type of error. We can see on the graph that it looks as though it continues with regard to what x values it can be, and so the domain would be any real number, which is -infinity to +infinity. And then the range of f is the function. It goes down forever. So the range minimum for f would be -infinity, and then the maximum value on that y-axis would be 32. We found that on that one point that we had determined up here, and that 32 is part of the y values, and so that's going to be part of the range. So that's going to be a closed bracket, not a parenthesis. Okay, so there's example 6. Let's go ahead and finish with example 7. So we're going to go back to our calculator, and we're going to type in x to the power of 2/3. Make sure that when you type in the power, it's 2 divided by 3. The whole thing is in the power. Okay. I'm going to go back to just a standard window to start. So we're going to go -10 to 10 for x, and then -10 to 10 for y, and we get this type of function here. So we'll just do a quick sketch. All right, so I'm kind of exaggerating it a little bit, but it looks like that. This particular function kind of looks like it levels off, but it actually continues to go upward forever. It doesn't, plateau and hit a horizontal line at any point. It just keeps on growing, just kind of slowly. So with regard to when it is increasing, that would be this portion off to the right, and then decreasing would be this kind of half of it off to the left. In terms of the domain, any x value can be put into this function. The x to the 2/3 can take on any value, so the domain is anything. The range, however, is limited from 0, which is included because 0 is okay, and then it will go up. Even though it's really slow, like I had mentioned, it will go up to infinity. The increasing interval for f would be from 0 to infinity. So that's going to be that section that I highlighted in blue, and then it's decreasing from -infinity to 0. Okay, I hope that's helpful. That's where we'll stop for this video. Thanks.